This video is sponsored by Brilliant. What is up guys, my name is the Cherno. Welcome back to another code review video. Today we're going to be doing something a little bit different again, because I like to mix it up with this series it seems. Last time I reviewed some C# code, I'll have that video linked up there if you haven't seen it yet, and you guys seem to like C#, so today we're going to be reviewing another C# project. This time it's going to be a game made in Hazel, the game engine that I'm developing. And also, the other thing that's going to be different today is that the person whose code we'll be reviewing is right here with us. So prepare to get wrecked. All right, so tell us a little bit about the project that we'll be reviewing today.
So it's a game made in Hazel. It's a Space Invaders clone, named Script Invaders, and it's something that was developed over the course of 6 months. Full disclaimer, guys, the code that I've written like in the last month is gonna be way better than the code that was written in the first month of development. We're gonna roast the files that were like in the first couple of commits because they're poorly written.
Tim's already roasting himself before
exactly. We've also made a video on this game that I've made. You can check it out in the video up there. That was the last video that we filmed.
Yeah, okay, sure.
You could just cut.
Now this game itself is currently only available to the partner supporters on my Patreon page. Eventually we'll be releasing this game for everyone, but at the moment we still have to like finish the engine first so that we can distribute games. So basically this is what the repository looks like. This is like the standard layout for a Hazel project. We just run this batch file, which will create some like solution and project files for us. Now Hazel uses Premake for all of its like project generation. We don't use CMake or any other build system. Premake is by far my favorite thing to use for this, so we also use that for the game. Let's go ahead and open up the solution and we'll take a look at what Tim's done. All right, actually, you know what? Before we do this, we should probably play the game.
All right.
So here you go. Show us what you've done. Okay, so this is a Space Invaders clone and you've made this intro.
Yep.
It's an intro cinematic. Yep. How much time did this take you?
Like 2-3 weeks at least.
Okay.
Yeah.
And you made all the art. Fun fact, you bought an orange for that orange.
I actually bought a physical orange, and then edited it in a Photoshop.
Original art.
Mm.
Do you want to actually show us the settings menu? Because I think we'll be code reviewing this, because this looks like it's made out of UI, but Hazel doesn't actually have support for UI, so you kind of made this from scratch, just in C#?
Yeah. Actually, like, this is one of my favorite parts of this entire game because of how simple it looks and just how nice functions. Okay. That's not gonna work. So you can switch out of the controller, but you can't switch back
right,
with the controller.
Selected a different controller.
It's now trying to get input from a
And it says
controller.
Xbox controller because we're just using DS4 to simulate this PS5 controller.
It's getting remapped to be a Xbox controller.
Yeah. All right, let's go and play the game. Oh, waves cleared. Is that new?
Yeah.
I haven't seen that. Oh,
and the held by.
Held by 10. Why do you have a high score on this computer? This is my computer.
Yeah, I know, but I beat it when we were recording the video.
Ah, okay.
And so I actually...
You beat my high score.
I beat your high score and I said my name.
It's unacceptable.
It's a little bonus for this video. Cherno did not know about this.
Alright, so there are a few stutters and frame drops here and there. That's not Tim's fault, which is, now I'm roasting myself. This is some of the engine systems like the asset manager have a few issues, we'll say. And we're working on them, so I'm working on them, so we will fix that. Now, those stars as well, they're all individual entities with C# scripts attached to them, right?
Mm.
Each star.
No, yes, possibly.
Okay, and this is the game.
I can't actually remember this.
Alright, and so you've also made this game over screen with the ability to type in your name, which also you did from scratch, right?
Yeah.
Because Hazel doesn't have that at the moment.
We have text components.
So,
that's all Hazel has.
Yeah, so we can render text, but this whole typing and this caret, that's all you from scratch.
Mm-hmm. That caret is literally geometry. It's a plane.
Okay,
that's
so
getting flipped 180.
We'll probably check that out, and then you can play a game, play again, or you can go back to the main menu as well. So that's the game. Let's take a look at the code. All right, so I've gone ahead and opened up the project inside Hazelnut, which is Hazel's editor, because this is a Hazel game. It's kind of like a Unity game, right? It doesn't really have an entry point inside the code that Tim's written himself. It's more so kind of, this is like the start scene, which is that intro that we saw. And then, okay, so you obviously made the character walk. If I hit play here, you can see the character's walking forward.
Yeah.
So how does that work? How did you architect that? And like, where do we begin looking at this code?
It's just, so the camera has a script, I think main menu camera. From memory, yeah, main menu camera.
Okay, main menu camera. All right, and so this is where the code for you walking is,
Yep.
right?
Yeah,
Bob.
it's just,
With a double B.
yes, because like bobbing, you know?
Oh, bobbing.
Bobbing.
But if you just bob once, isn't it just B-O-B?
Yeah, but it's constantly bobbing, so it's bob.
No, fake news. It's just...
Okay. Welcome to this episode, Tim Learns English.
You clearly didn't check out that brilliant course that I told you to.
I have.
Really?
Yeah.
Which one? What do you mean you don't know which one? You were just doing it.
Computer memory, right?
Yeah.
Is that what it was called?
How's that going? Let me log in and look at your progress.
Oh, no.
Computer memory layout. So how has this been going?
Yeah, good. Look, I got the right answer.
But 88% of people got this right.
Right.
So you shouldn't feel
I'm in the top 88 percentile.
88%. So how has the brilliant experience been for you?
Yeah, it's good. It's really interactive, and that's something that I find helps my learning in general, is when I can practice what I'm learning.
So Brilliant is an amazing website filled with courses on various STEM topics, such as computer science, which is what Tim's been looking into. The thing that makes Brilliant, in my opinion, a lot better than other course websites that I've checked out is the fact that it's super interactive. Like, they have all of these various things to play with. Like, in all of their courses, they ask you questions, such as like in this one, right? They keep you engaged and they make you practice what they teach you. I always say this, by the way, that like when you're learning programming, you have to stop watching videos, you have to stop reading books, you have to actually start programming.
Yeah.
Right? Like, learning a musical instrument is my go-to analogy for this as well. Like, if you're learning how to play piano or guitar or something, and you just read books and watch videos and you never pick up a guitar and start playing, like, you're not going to, it doesn't matter how much time you spend on that. You can't just pick up a guitar and play, even if you know everything perfectly, because your fingers have never done it before. You don't have any muscle memory.
Yeah.
So it applies like to literally everything, including all of these STEM topics. Since Brilliant is there for you to actually keep you engaged and involved and practice what they preach, right? It's just so much easier to learn stuff with it.
Yeah, it's the same with languages as well.
Yeah, you've been learning French.
Yeah. Most people just learn the grammar of a language, but they never actually practice it.
Yeah,
And
which, yeah, is very...
entirely useless.
Aside from computer science topics, they also have a whole bunch of like math topics, and all of these topics are extremely like interactive.
Yeah, which makes the entire learning experience just not only easier, but entertaining. And I find when you make something entertaining, learning it becomes easy.
You'll kind of want to do it.
You'll want to do it, exactly, yeah.
The best thing about Brilliant is that you can get started for free. However, Brilliant have a special offer for the first 200 people who sign up using my link in the description of this video. You guys will get 20% off an annual membership. So go ahead and browse through all of the amazing courses that they have. Huge thank you to Brilliant, as always, for sponsoring this video. There's so much stuff here.
Yeah, it's a pretty big file.
Okay, so let's begin. So main menu camera. Now the other thing is I haven't actually taken a look at this code. I've helped Tim here and there while he was developing this project, but I have never sat down and read the code. So I've seen maybe 1 to 2% of the code. How many lines did you say this project was? 4,000?
Just a bit over 4,000.
A bit over 4,000 lines of code. So there's actually quite a bit to this. So a lot of these classes are Hazel classes, like a Vector 3 is a Hazel class. Material is like a material that we use for rendering. Mesh component is like an actual mesh. Like, I assume arcade sign was the arcade sign.
Yeah.
This one up here.
Yeah.
So all of that. So why does that? Okay, so that has you've made that a variable because why?
So, okay. The current workflow is that each of them has a red material. And so what I have to do is, like, there's 6 letters, each of them has an exact same copy of the material.
Right.
Because I can't dynamically change materials.
Oh, right.
And by changing the material of one of them, it would change all of them.
And you're making the letters change.
Yes. And
I
so
see.
Each of them has, even though they look identical, each of them have different materials that are just the same.
Yeah, okay, I see. So there they are.
Otherwise changing one of
Text
them will
0,
change
text 1,
all
text
of them.
2, text 3, all of that stuff. Okay, and then so on create, when we actually spawn in and that camera entity gets created, we're retrieving some components, find entity by tag arcade, get component. Okay, so like a few C# general things here. So we're getting the transform component for like the arcade sign and all that stuff. The problem is if this returns null, then this will crash. Right? Now I would argue that in this case, like, if this returns null, it's kind of a critical error. Like, why is that returning null? That shouldn't return null, right? So what we should do instead, and there's a few things we can do, right? If we kind of write this out in a traditional sense, which I feel like programming is becoming less and less traditional, and now it's just fancy syntax for everything. But what you could do is you could try and like find this entity first. So we could have like arcade entity here, right? And then if that isn't null, then, of course, we can try and actually access it. Because whenever we have something like this that is capable of returning null, because if this doesn't find anything that's called arcade, it will return null. So what I want you to think about is every time you kind of, you know, call a function like that could return null, in your head, you should kind of consider, like, okay, what will happen if that returns null? Now, again, sometimes that is like, you know, it can happen and it's an actual error, right? Like it's okay to let your code crash, one might say, if the thing that has happened is not permissible under any context.
Yeah, which I think in this case, if we look at what arcade is, it's the actual mesh of this entire like scene. So
Arcade, this thing, right?
It's this entire
building.
So if this is null, we don't have a scene really.
Well, that's kind of what I mean. Like something's clearly gone wrong. And then the other thing to consider though is that again, if this does in fact, like you've misspelt this or whatever, like you've called it something else, like that's also kind of fine, because if we, like, it's not going to be, because the C# kind of virtual machine is hosted by Hazel, like Hazel's not going to crash because of this. Like we'll run this. If I just recompile this code real quick and we pop back into Hazel, if I hit play, then like see, Hazel's not going to crash. Like the script's not going to work. We're not moving forward anymore. But you can see that we just get like a whole bunch of this null reference exception here. So it's kind of okay when you're scripting to not worry about this, like, because if this was actually part of the editor written in Hazel, then we would just crash and that would be like a problem. But still, like in terms of kind of code style and all of that, you could be a little bit more defensive by writing code like this, which again, these days with the new fancy syntax, you could just write something like that. Which basically says that like, if this is null, then it's not going to call this and it's actually just going to assign null to this. Right? So if this fails, you get null. But if it succeeds, then you can retrieve this and then get either whatever this returns, which could be null or something else, right? So that's one way to kind of do that. Now, as a side note, in Hazel, like you don't have to do this at all. You could just make a public entity called arcade. Let's just call it like arcade building or something. Now, in fairness, I don't think this may not have been around.
I don't think it was. I think after, like, I remember Peter mentioning this is a thing after.
So we can actually make a public entity called arcade building, and then if I recompile that and just reload the C# assembly, then if we go back to the what was that, the camera?
No, arcade.
Arcade. No.
It was on the camera, yeah. Arcade building.
If we go to the camera, you can see we've got that arcade building, and I can actually just take the arcade and drag it in here, and now we don't have to do that find entity, and that's actually a bit faster, because obviously, like, by dragging in that entity, it's just using the UUID. It's not going to use, like, it's not going to try and look it up by its string, which is like stored in something called a tag component. So that's actually an even better way of doing that. But yeah, in general, just kind of to make an example out of this, be careful, like whenever you call a function, just consider in your head what happens if this is null. Like, is my program going to crash? Is this fine? Because whenever I see chains like this, I get slightly nervous. I mean, like get component, I think, actually defensively checks if it has that component. Otherwise, it returns null. And I don't know what this hack is. Someone else must have written that. This is already Hazel code, so this could be just from the Hazel team. Oh, this is just a hack because now we have two. Yeah, I should probably fix that. I don't know who wrote that. Anyway, moving on. So good. So you retrieve the arcade, and then we go through. We get the controller ID, and you go through and you retrieve every single. So arcade letter, you go and get all of these, and then you set. Okay, so you're like in a for loop. You're assigning this to basically 6 different materials. So why are you doing that? Because obviously you're overriding it.
Yeah. Yeah, and that's fine, because if we go to the scene, the arcade sign has like 7 different letters or whatever. 6.
Yeah, but
6 different
I guess
letters.
my question is, why are you setting that into a member variable? Like, why aren't you using a local variable for this? Because you're obviously not using it outside. Yeah.
Well, no, because it
You
happens
use it
on every...
eventually.
Yeah, if you go into update, or like there's a function that's eventually called, and that gets called every couple of like seconds.
Yeah, but that's just applying to this one.
Yeah, but that gets changed at the end of that function, I believe.
Which function?
That function that calls it later on.
Oh, here.
Yeah. So
Yeah,
it gets
which
the
again
next
is
one.
fine, but just for this,
Right.
I would just say, you know, var or whatever, arcade letter, and then kind of make it clear, because you don't really need this. Like, again, it's not a big deal, I guess. Like, if you really want to get pedantic, like maybe, you know, you're writing to memory that's kind of not local, especially if this was C++, but it probably doesn't, in all actuality, probably doesn't matter too much. It's just like, my problem with this is that it implies that like something is persisting outside of this for loop.
Right.
I guess like a really good general rule of thumb for programming as well is the tighter the scope, the better.
Right.
Right? You don't want to let stuff float in, like, essentially the largest scope we have is global.
Sure.
Right? It doesn't really exist in C#, but we can have static things in classes, and that if that effectively is global as long as it's public.
Right.
Right? But in general, like, even inside something like this, like, you know, like, you wouldn't make this I variable out here and then use it here.
And then use it
even
here.
though
Yeah, that makes
technically
sense, yeah.
speaking, obviously that would work.
Yeah.
Right? But we try and control the scope as much as possible.
Right.
Okay, so for the first iteration, you set the emission to that. Otherwise, you set it to that. So, yeah. I mean, that's okay. Like, if we... Okay. So, we're going to get pretty deep into this.
Yeah. Which, okay, can I defend myself before we start roasting? Right. So, right now, Hazel at the end of play doesn't reset what the
Right,
material...
so you roast me.
Yeah. Let me roast Cherno before he roasts me, okay? So, Hazel doesn't reset. This letter E will not be reset. If we get rid of that, like, set it to 2, it'll stay darkened like this. It'll stay 0.75 until it iterates to this letter, lights it up, and only then will it turn off.
Because Tim's code, like, permanently modifies the material, basically.
Yeah. And we have no way of temporarily modifying material. So, yeah, go on, roast me. Anything else to
I
add?
was actually it's not even, I was gonna just mention your programming, not the actual what you were doing.
Okay, alright. Now I'll get roasted.
So, like, whenever I see stuff like this, like, it also kind of bothers me on a microscopic level.
Okay.
And the reason why it's on a microscopic level is because it's not a big deal.
Right.
Like, a lot of this stuff is not a big deal. Like, okay, so what's a big deal to me? A big deal to me, let's talk about what a big deal means.
Right. What is a big deal?
So a big deal is when you write code that actually makes the experience for someone, whether that be a developer or a user, worse.
Right.
Right? So how would it be worse for a user if the game just performs like garbage because of the code you've written?
Yeah.
Right? Performance is probably the biggest thing for a user. Unless it's also... Because the other thing is, like, most other user experiences, like UX, literally, or UI and all of that stuff, that's kind of managed by UI people anyway.
Yeah.
So as an engineer, you're not really affecting the user experience in ways that is other than like, oh, this is just slow. Because you're implementing something that someone else has effectively designed, and the design is what can kind of affect users negatively.
Yeah.
Whether that be like as simple as like, I can't go back in this UI menu for some reason, or like, you know, my inventory, like in my game, is just really hard to use, or like I can't trade this sword for another sword, or you know, something like that, which again is game design. So as an engineer, usually it's performance. Now, the other thing though, as an engineer, is you have a responsibility to all the other engineers to write code that is not bad.
Right.
Right? Like, you don't want to write code in a way that no one else can understand.
Yeah.
And you don't want to write code in a way that like will make other engineers' lives more difficult because if a designer comes along and says, actually, we need this,
Yeah.
and you've written the code very, very specifically down the path that was present at the time, then that's bad because then the engineer has to be like, I'm gonna have to rewrite this whole file now, and that's also bad. So if we take a look at this code, none of those really apply, and that's why it's a microscopic annoyance. Because I can't tell you that, like, so let's talk about what even kind of slightly annoyed me in the first place. It was mostly just the fact that if I look at a for loop and there is an if-else branch in there, like, as someone who, like, spends a lot of time optimizing and low level and all that stuff, this branch immediately bothers me because it's a branch that only applies to the first case out of 6.
Okay. Yes.
Right? So technically speaking on paper, a better way to write this would be, let's just do this first thing outside of the for loop, right? So if we basically say, let's grab like arcade letter 0, like this, and set the emission to 0.75, like this, then that means I can start this at 1, and guess what? I've gotten rid of an entire branch.
Right.
Now, will this produce faster code? Probably not. Like, no one will ever see this. Yeah. And guess what? This is, I would argue, more complex.
Right.
Right? Because first of all, this code is duplicated, right? We only used to have this in one spot. Now we have it in 2 spots.
Yeah.
This for loop starts at 1, which surprisingly to some engineers is difficult to comprehend. And they'll be like, you can start for loops at 1? Maybe I'm reaching here, but I've seen that happen before. People have been like, shouldn't this be 0?
Isn't it always I++?
Well, yeah, sometimes it's I minus, sometimes it's plus equals 2, sometimes it's whatever, sometimes there are multiple statements in these things, sometimes this isn't like you just might be calling a function or something, like, there's a lot of variations for your for loops. You can put any code you want really in here, right? It doesn't have to be this. But the point is, like, so I would argue that, like, you could say that this is better for an engineer, right? And like to actually read, like code, like reading the code wise, like this could be better, right? Like for people to read and stuff. But technically, in terms of performance, maybe you could argue that something like this is better because again, if you think about it, this is almost like you're slightly unrolling your for loop. Do you know what unrolling a for loop is? Unroll.
Well, taking stuff out of it, right? Is that what you mean?
Well, no, it's basically converting the for loop to not be a for loop.
Oh, okay. No,
because for loops, technically speaking, also have a bit of a performance overhead.
Okay.
Right? Because you have to keep track of like this I variable, you have to keep checking this condition.
Right.
Right? This might not be necessary if we, for example, just imagine if you took this and you just unrolled the for loop by literally doing it like multiple times like that. Right? And then we would just say, well, like we could just call this arcade letter. Let's just get rid of all like the vars. And then this, of course, is just going to be 1, 2, 3, 4, and 5, right? And like, again, we've done the same thing that the for loop did.
Yeah.
It looks way worse, but it would perform a bit faster.
Right.
Right? Because it doesn't have to do like this comparison. There's just less overhead. It doesn't have to jump around as well. I don't know if the jumping is that slow, but it's definitely like an instruction versus just going down, I guess.
At an assembly level,
move
right?
the instruction. Yeah,
Isn't
probably.
it like a go-to statement or something like that?
Well, it'll be a jump statement.
Jump statement,
in
right.
assembly, yeah. But anyway, point being, like, again, I'm not saying you should go ahead and like write code like this now, but I guess like what I did there was just an example
Unroll
of
it
like
a little bit.
partially unrolling it.
Yeah.
But again, the reason I've unrolled it is not to save one extra jump and comparison instruction or whatever. It's specifically just because
Of the continuous if statement.
by doing this, unless the compiler, like that's the other thing, right? Compilers are smart. C# virtual machine is also smart, right? So it's possible that it can see this and be like, well, I will transform this because this is a constant effectively. Like 0 is a constant.
Yeah.
You're comparing I to 0. So I'm not a compiler expert by any means, but it would be feasible for a compiler to look at this code and be like, okay, you've got something that applies to the first iteration of this for loop because it starts at 0, and then this branch literally does nothing. Like it's always going to hit the else.
Yeah.
Because there is branch prediction and all of that stuff, although that's more of like a CPU runtime tech thing. But anyway, point being, maybe the compiler could save you here. And again, this isn't like, we probably spent way too much time on this because it's not even that important.
Right.
But I guess just an example out of this would be that just think about these things.
Sure.
Right?
Right.
Anything to add?
Well, okay. Initially, when you said, like, I don't like this if statement, right? The way I would have rewritten it would be like this. And then just get rid of this. Would this be any better at all?
Probably not.
Probably not.
No, like the
Worse,
reason.
though? Worse?
Well, look, I mean, if and if else, like you're already paying the cost for the branch,
Right.
right?
Okay.
Because this might look like an if to you, but actually, what's happening is it's going to compare I to 0, and if it's equal, then it jumps to this line of code,
Sure.
and if it's not, it jumps to this line of code.
Right.
So it's already doing a double jump.
Okay.
Right? I mean, I guess, like, if you had it as else, then it would jump first to this and then to that.
Yeah.
So maybe that's... But my point is it's still jumping,
It's
right?
still doing the
Whereas...
Okay.
And you're also assigning every time,
Yeah.
which, again, is okay. Like, none of this matters. Right?
Okay.
Let's just make this clear. This code review does not matter. But if we're being really, like, microscopic here...
Right.
Then, like, that also is a performance penalty. And again, because you haven't gotten rid of the branch, it's still there. It's just you've slightly modified it, right? It's not really going to. If I don't know. I think it's about the same, to be completely honest with you.
Okay.
Yeah. I thought you. I was full on expecting you to rewrite this code as like this. I fixed the branch, but I'm glad you didn't.
Is this bad?
Well, it's the same thing.
Right. Okay.
Is this bad? We should probably cut that out. But that being said, I probably would write it like this if you kept the branch, which you are. We've decided you're keeping the branch because it's silly not to.
Yeah.
Right? Just because this kind of, it just compresses it a little bit.
Sure.
And you're basically saying, okay, in the first iteration, 0.75, otherwise, we're setting emission to 2 everywhere else. Okay, moving on. So, okay, we have a bunch of point lights, which you made flicker, right? Which again, I would change them to not kind of find by tag. And like the thing is, like these things, like I haven't profiled this function or anything, but I'm sure that it does kind of add up. Like, because the thing is, when you make a game on this scale, which isn't like a huge scale, but it's bigger than like a little test scene in Hazel, right? Every little bit adds up. And again, like my recommendation would always be, okay, find entity by tag. Like the way that this function works internally is it basically has to iterate through all the entities, looking for all the entity tag components, which are actually stored contiguously in memory, right? Because entity component systems group components in kind of contiguous cache lines and everything, so they're fast to iterate over. So it would, but it would still have to iterate through that list of components, of tag components, to find that flickering light 0 text and do a string comparison for each of those. And because obviously nothing's sorted or anything there, like there's no, it could search every entity in the scene and do a string comparison with each of them to try and find this. Right? So like it will actually grow in complexity.
Sure.
But obviously with the UUID thing, right? The way that we that also has to somewhat do a search to link, like to find the actual concrete entity inside the entity component system based on the UUID.
But that's already a map search, right?
Yeah. That has a different complexity. That's basically like an order 1 type deal. Like in certain situations might not be, but usually is. And also, there's no string comparison because this isn't like, we're not hashing this string or anything. It's just literally a string comparison. So that's also not great.
Right.
So just kind of think about like, performance implications. I think like, if anything, like, you know, as you grow as an engineer, like, especially in the games industry, like just consider performance pretty much everywhere.
Yeah.
Right? And again, consider performance definitely does not mean optimize absolutely everything.
Right.
It just means just have it in the back of your mind. Like, just start thinking about, that's what I want you to do, is you write more code.
Yeah.
Just whenever you write a line of code, just be like, what does this do? Like, what does this actually do? Like, what does the CPU have to do to do what I'm asking it to do?
Mm-hmm.
Just kind of think about that.
Yeah, okay. And maybe I should add a disclaimer here, because there was code, maybe still is, in the game, what's called in the game files, where I was doing this stuff on update, where there was, like, it was searching for the same entity on update, like, which, like, you know, if I saw that stuff now, I would at least move it to on create, which gets runs once, finds it and has that entity. But yeah, so in case there is stuff like this still on the update function, I would not write that stuff today like that.
Okay. Sure. All right. So yeah, setting up a bunch of variables here. This is kind of a large file, right? It's not that big. It's about 400 lines of code. But the problem is, like, if we take a look at this file from above, like this, a lot of it is variables.
Yep.
A lot of it are specific variables for specific actions, like animation timer, you know, flicker time, all of that stuff.
Yeah.
Right? And even if we zoom out even more and we take a look at your general project structure, like, I don't like the fact that there isn't a single folder here.
Oh, okay.
Right? Like, we have folders, like, well, computers have folders, right? We can group this a little bit in a better way. Again, not a huge deal, because it's not like this is getting in the way. If Hazel was all in one folder, that would be really annoying.
Yeah.
Right? So the folders aren't a huge thing, but it's just something that I noticed. But one thing I would definitely do here inside like this main menu thing, is because there's so much stuff going on, is think about how you can actually, like, separate and make the code more generic as well.
Okay.
So I know for a fact that this game that you've written has a ton of different animations. Right? Animations that need time to be kept. They then need to put variables into, like, a lerp function, and you have all this animation stuff. So I think what you could have done is just written, like, some kind of animation utility class to help you out with that. Right? And anytime you instantiate that animation object, that would automatically have, like, a start time and end time. And then you could basically be like, hey, I want to make a new animation. It takes 5 seconds, right? And then you just, like, automatically could add that to an animation pool where all the animations get called, like, on update or whatever gets called with time step, so that it can kind of update everything at once, right? And then that way, like, all of this stuff disappears, and you don't have individual floats keeping time, like, for a lot of things. Yeah. Right? Okay. Now, of course, not all of these are a simple lerp from point A to point B, right? So you don't have to, like, I don't want you to make the code too generic, because when you try and make stuff generic, then it just ends up sometimes being just worse, more complex, slower, you know, all of that stuff. Okay. So you don't always want to do that, but, like, at a minimum, like, I think something like, because I know that, like, you know, all of this time, you know, you're incrementing it by the time step. Yeah. Right? So you should be able to recognize common patterns like this, because this plus equals time step, like, it happens in a lot of cases, right? Here's another timer, here's another timer, here's another timer, here's another timer. These are all timers. You know, why not turn these into animations? And then that way, again, it would add some more context. You wouldn't need to keep track of the time and do any of this, because you would just go through, you would iterate through all the animation objects and then just do dot on update or something with the time step. Yeah. It would do that internally. And you could even set a speed for the animation. You could do a lot of stuff there, right? Okay. So that's something that I want you to think about. Right. Maybe that's an exercise you can do a bit later. Sure. But then the other thing is, at a minimum, grouping stuff together. Not on different lines, you mean just comments? So what I like doing... Yeah, but you could also group them into, like, a struct. Okay. So this is something, to be fair, that I mostly do in, like, C++. Right. But if you use a struct in C#, it's not also going to have a penalty. Like, I wouldn't make a whole class out of this, but what I mean is you could do something like struct, you know, Bob or something, right? With the Bob stuff. And then that way, like, all of this stuff that you have, such as timer, Like, you don't have to now suddenly be like, don't Bob. These are all booleans, but, you know, Bob timer, right? Like, you can basically add some context to this, where now you don't have, like, Bob timer, you just have timer, right? And then this is the timer for your Bob.
Right.
Yeah, and then you just have, like, a little Bob, and it's a struct, so it should be all nicely, like, it'll be, like, allocated on the stack and everything. It should be fine. Like, it's not really slowing down the code or anything. Right? If it was a class and it was like a heap allocation, all that stuff, yeah, definitely not. But with this stuff, like, it's kind of okay to do this, and that way, again, you're just grouping stuff a bit better.
Yep.
Because look, there's Bob stuff up here, there's Bob stuff down here, there's don't Bob, there's bobbing is
There is a lot
everywhere.
of bobbing.
And it's all also just infuriatingly spelt with a double B, which
Well,
is the real problem
Bobbing is spelled with a double B, and one Bob is not what happens. Multiple Bobs.
Yeah, but you
happen.
don't add a double B to make it plural. Bobs would have been plural.
Make
okay,
a quick
so
movement up and down.
make a quick short movement up and down.
Alright.
You see how it's not like... You see how it's not...
I mean, Google yielded the same search result.
Well, yeah, probably for people like you.
Or,
Bob, I understand that you add a B,
yes.
like, when it's past, but the Bob... Bob's, third person
Bobs.
present. Bob's, bobbing.
Bobbing, yeah.
Anyway. Alright, so we just ate an entire chicken for lunch. We're back now to do some more code review.
The chicken was good, in case anybody's wondering.
Yeah. Are we going to review the chicken? So where actually were we?
I think you were telling
Like
me about
several hours.
a struct that's wrongly named Bob
Oh, Bob.
with one B instead of two.
Yeah. We had another chat about the spelling of Bob, by the way. So it took a while, but I think you conceded.
No, I conceded, but then Cherno kept on talking, and now I'm back to my original point of view that I'm actually right in writing two B's instead of one.
If anyone out there's looking for a job who spells Bob normally, we've just had an opening. The main thing I think we were talking about was the whole time step thing,
Yeah.
right? So again, animation class, abstraction.
Yep.
Another thing we talked about over lunch as well was that it's important not to go too far into making things generic and abstracted, because remember that at the end of the day, like, abstractions are mostly for you as the programmer. They're not for the computer, right? Like, if we look at this, like everything I've just mentioned, like having a structure called Bob and all of that, right? The computer is like, your CPU is not going to look at this code and be like, oh my gosh, you've got so many like floats just floating around, right? This is ridiculous. I can't deal with this. No, this is actually way streamlined and ready to go, right? Compared to if you start making all these classes and systems and all that stuff and jumping around functions and, you know, whatever, right? That's when it actually becomes harder for your CPU to deal with, right? So just remember with abstractions as well, and I could talk a lot about that, which I might do at some other point. It's important to also balance that.
Right.
Now, since we have already been here for we started recording this video like 4 hours ago. We did have a long lunch. But anyway, what do you want me to look at? And what do you think are the problem areas that you would like some help and advice with?
Right. So like I said, the older the code is in this game, the worse it's going to be. One of the first files that was written was alien controller.
Okay.
That makes them move across the screen.
First file.
And yeah, if I was writing this today, it would be way different. But I haven't rewritten this, so I think it'll be good to take a look.
Sure. Actually, I just remembered one thing that we initially opened this file because we wanted to take a look at the bobbing. Right. We got distracted by your variable naming. So
That's actually my strategy with working for Cherno. Just name stuff in a confusing way that he never looks at the actual code. Yeah.
Yeah, it's very distracting.
He gets lost at the name, so he never checks the code.
Very superficial.
Yep.
Now, with this, right? How did you make it move from one point to another? Because, we know that effectively what you've done is, if this is a top-down view of the room, you start here, you end up at the arcade machine, and you kind of move like that, right?
Yeah.
So how does that work in the code?
It just lerps from one. This manually sets some targets, I think.
So where are they? What are they called? Do you want to show me?
Target translation. This is the first one. And I think that gets updated once you reach it. So when the lerp finishes... So yeah, there's a couple of things, once you've checked out the posters, it sets it to the final destination.
Okay.
And sets the rotation as well. Obviously when it's looking between the posters, your translation's not changing. You're just rotating the camera essentially. And M transition, I think, is by default true from memory. Okay, no.
Oof, look at those nested if statements.
Yeah. This was rough.
This is rough. This
I
is
remember
rough
I was
present.
stuck. Yeah, this is rough present. Like, the reason why it took me 2-3 weeks to write this was actually because of, like, bugs in this, and finding them was just rough.
Okay, I thought you were going to say Bugs and Hazel, but that
No,
doesn't exist.
no.
So.
M transition that's when it stops being like a walking and starts like flying into the arcade machine.
Okay, yeah.
But again, this is written in such manner.
Can you go to the walk function?
So essentially, it's just looping from initial to target with a timer.
Okay, why does it say if not, don't Bob, then
Yes.
Bob?
Then Bob.
So I can't
With a
believe
double
you.
B.
You
With a double
literally
B.
choose double B everywhere.
Yes. Hey, even if my naming convention is wrong, at least it's consistent.
Can you guys like leave a comment below what you think the actual spelling should be? Because like, I mean, this isn't like, we don't really need to be asking this question. But
Right.
for the sake of Tim,
Right.
let's just...
You see, you have to have a look at the context here, right? YouTuber, nearly 500,000, nobody, an employee, right? If I'm wrong, what do I stand to lose? If you're wrong, that's just embarrassing.
Well, luckily for you, I believe in improving people and
Right.
investing in people,
Right.
not discarding them.
Yeah.
So it's going to be okay, even if you're wrong.
okay,
But you have to concede, and I'm going to need that in writing. Okay, so let's talk a little bit about what you've shown me here.
Mm-hmm.
So one question I have for you immediately is how, like, all of these things, like, there's obviously a lot to unpack here.
Yes.
And, like, the level of indentation here is slightly worrying me. And we can talk about why that's bad.
Yeah.
But I think you maybe understand why it's bad. Like,
Yeah.
you're very deep in this logic, and like, again, this is a very perfect candidate for something called a state machine, where you basically have a whole bunch of states, right?
Okay.
You've solved this by using booleans, which is what we see here, right? But what you could have done is you could have basically designed like a state machine, and at its core, like, that could have just been an enum with basically all these different states. Like, for example, initial walk, then this, then that, then like whatever, right? And that way, again, all you would have really needed is some kind of either switch statement, or you could have even set up like a map of functions with lambdas. Like, you can go into this pretty deep, right? And I might actually rewrite some of this code. Maybe I'll show it in a video. Maybe we'll just do this privately. But I'll show you how to convert this code into that, because that will be a good learning experience, I think. But ultimately, like, yeah, this is bad because there's a lot of points of failure here. It's hard to read. If I'm looking at this code, like, what state am I in? Well, I'm not in this state, but I am in... Oh, I'm also not in this state. Like, you know what I mean? I'm not walking, but I'm not stopped walking. So does that mean I'm actually walking? Because this is walking, but
Yes.
I guess in this branch I'm not walking.
Yes.
I am transitioning. I'm not transitioning. I'm not even joking.
And yeah, let's skip that.
This is my experience reading this code.
Right.
And is that it? Yeah, thank
Yeah.
goodness. All right, so anyway, it doesn't matter. My point is, like, that's why it's not good. But the other thing that's kind of interesting to me is, like, for example, this target translation. How did you come up with these numbers? Like, how
I
did that
physically
work?
moved the camera to that location in the
And then
scene.
you copied that.
Hit play without it moving, just to see what it would look like, and then yeah.
Okay, yeah, I think what I would have done if I was you, like, that's kind of what I thought you did, and that's okay, but the problem is, like, you know, these values here, right, I don't like the fact that they're effectively hard-coded,
Okay.
right? What I probably would have done is I would have moved, like, you know, whatever, you can hit play, and then you can, like, if we hit stop here, I was gonna hit pause. If I hit, like, pause here, and then I click on the camera, I can move it around, right? What you can do is you can actually, like, position this where you want, and then maybe create an empty entity called, like, you know, marker1 or something. I probably would have given it a more descriptive name. Maybe we could make a little parent entity called markers, not for the sake of parenting, but just for the sake of like organization. So now we have marker 1, and then we could shove those values like in marker 1, and then have the camera basically have some kind of array of markers or something, or maybe named markers, being like this is marker 1, marker 2, and then I would just drag that marker into there, like into wherever I need to here, so that then basically what I have is these like, you know, and if we look at these markers, obviously, they have like, I don't even know, I'm in play mode still. I made that in the scene.
Yeah.
I made that in the play scene. Well, whatever. I have my marker 1. Anything you make like during the scene runtime is that's it. It gets lost because it was in the runtime scene. Anyway, you can see like we actually have a physical position for this marker in the 3D space. We could even add maybe like a model that is only in the editor view or something, right? But the point is you can kind of position these markers in that way, like you can almost have a visual path, right? Again, if we had better cinematic tools, because you made a cinematic, like this was, we didn't talk about this at all. You just decided to make this thing, right? Which I think is really cool. Like I really like it. But obviously if the engine had cinematic tools, this experience would be very different. Like you wouldn't be worrying about doing this like in play mode or whatever. You'd literally have a timeline that you could scrub through and then you could position things. Like it would be much easier, right? So you've done a good job here. But like I would just try and use the advantage of a visual editor as much as possible. This applies to Unity, obviously. This applies to any engine, right? Like you have an editor, right? It's important to utilize that as much as possible, even if it means the fact that you can visualize a point by having to, by actually setting it up as entities, rather than having to, you know, go through the camera and copy values into your code.
Yeah.
Right? Like that would be a good candidate for that. And same with rotation, because the thing is, like at the end of the day, this obviously has an entire transform. So of course you can rotate this point however you like, right? And as a test, you know, you could even add a camera to this, right? Maybe mark it as the main camera. I don't know if our main camera system works.
It does.
It does.
Yeah. But you have to uncheck it on the other camera.
Okay, so if I uncheck main camera and hit play,
it'll now go with this one.
Yeah. So see, now I have that second camera I created, and then of course I can orient it, and that's the translation. I can orient it like however I like. So there we go. Have it like pointing down or whatever. Maybe no tilt. Keep pressing that. And then set that, and then these values are perfect. It'd be nice if we had a way to copy this into the save scene or whatever. Oh, what happened there? What was that? Oh, that was at the end or something?
Yeah.
What?
Because the camera still lives. And when it gets to the certain translation, what I do is actually move the entire arcade back a little bit, because like a little
to
bit
get it fly
clips.
through.
No. Because like once it flies through and it's perfectly positioned from the text components and stuff like that, you can still see a bit of arcade.
Oh, so you
So I
just
move
get it
it a
out of the
little
way.
bit, yeah.
Okay, sure, that's kind of cool. All right. So yeah, so that's just my one piece of advice here is well, two pieces I guess. Is the state machine, having a state machine for this would just organize this way better. And then of course you could, at the end of one state, you could progress to the next state or to a particular state. Right. And then obviously with these like locations, like whenever you have hard-coded values like this, think about like maybe that could be an entity, and then that way I could just again get the target translation rotation could be like a target transform or something, and you could take it like from an entity, and then that way you have a visual reference for all of this. Whereas this, of course, and then the other big thing is these are like world space, aren't they?
They are, yeah.
Yeah. See, so if something moves, then you kind of have to adjust these values, don't you?
What do you mean something?
Well, I don't know. Like, let's just say you, I don't know, move the arcade a little bit, or like
it's obviously not aligned anymore. Yeah.
Whereas, like, if you had something that you know, like for example, you have this base mesh that's the arcade, you could even make that marker like you you can make it part of this, and then that way, obviously, if you decide that the arcade moves, like that marker has also moved. It's over here now, right? So it always stays kind of in that same place. Right, I don't know where this is supposed to be. I have to reload the scene because we don't have an undo system.
We don't have an undo system, yeah.
Main menu.
But there's many benefits to that.
Yes, as we discussed. Okay, so you mentioned alien controller.
In
So walk me
particular,
through this.
one function.
Okay.
So essentially,
So what does this do first of all?
moves every single alien, which is a rigid body in the scene.
Right, so in this Space Invaders scene.
Yeah. So if you go Control P, it just moves every single one of those rigid bodies.
Okay.
And you know, if you get hit by one more bullet, it'll also be responsible for rotating them.
Right. And there's a physics collider on the camera. That's what this thing is, right?
Yeah. So now and again, like shards of the aliens hit the camera, and it like kind of simulates a little collision.
So yeah, all these green things are physics colliders, by the way. Control P, was it?
Control P, yeah.
Oh, didn't even know we had a shortcut for that. All right, cool. So what's the function?
I think it's just move something.
Move aliens?
Yeah, move aliens.
Okay. And you just want me to look at it, or you have a...
Yeah, so have a read. Okay. Because, okay, I have to do... Essentially, there's some edge cases, right?
Okay.
At its core, you're not doing anything other than like, hey, I've reached this point with my edgemost alien. Go the other way now.
Yep.
The problem is, how do you go the other way? I have like a speedware variable, which multiplies the movement, like vector right times speed. So when speed is negative,
horizontal.
Vector, yes, yeah.
Yep.
And so when speed is negative, it will obviously be vector left, the other direction.
Yep.
The problem is, and you can kind of see this in like debug when we have like less frames per second. When they move at a larger like step as well, because this is actually like in delta time here being calculated. The problem is sometimes they go outside of the like edge, and just by one iteration of like, hey, I'm moving left now, they're still outside of that like I don't know, I guess marker in world space. At which point speed gets set to what it was the frame before. Which becomes positive, which means they're going in this direction. And so what you get is this like every step they're switching, and they go, instead of doing the whole length of the screen, they do like just one step in each direction.
Yeah, I get it.
We spoke about this when we were talking about kind of like making a bulletproof game, even when like frame drops, so that they will also always be on screen. This is kind of like the perfect use case for it, I guess.
Yeah.
Which it's not doing any of that at the moment. In fact, like I have a move aliens down function, and there is another function, I think, move aliens across.
Okay.
And that's what makes sure of the fact that, hey, I'm now not gonna set that flag off if I just go into that speed direction.
Okay. Yeah. This is a bit tricky because it seems simple, but there are, as you mentioned, edge cases. Literally, no pun intended. But the problem is, like, if we break this down, I actually think that, like, the whole way you've gone about this is a bit wrong and maybe not how I would do it. Because the thing is, the thing that's unique about Space Invaders, I think, or the thing that we can take advantage of with Space Invaders, is that these do not move smoothly. Right? They jump.
They jump, yeah.
So that is actually a huge advantage, I would say.
Okay.
Because what that means is that you can effectively set this up as a grid.
Okay.
With cells.
Right.
And I honestly think that that's probably how I would do it.
Okay.
Oh, it's the music from the game.
Yeah.
I was like, what does that sound? The reason being that, like, if you think about it this way, like, the problem is, again, each alien here is being moved by a particular value, right? That value, you're kind of, like, you need to consider, like, usually we would like to feed into the time step for that. Because if we do that, like, if we have a 144 hertz display or something that isn't, like, 60 or whatever, varying frequencies, we can produce smoother movement by rendering more frames in between and moving it in smaller increments. Not exactly what we want to do, probably, with Space Invaders, right? We want it to be, like, sharp, and we want it to snap.
Yep.
And whenever you have the problem of I need this to snap somewhere, right? For me, a grid comes to mind immediately. Right. Because if you have cells in a grid, then all you have to do is snap to that nearest cell, or even better, just have basically the entity position be a coordinate within the grid, and then you just have an index, an X and a Y index. And that's actually really useful because, again, all you have to do is move each alien one cell to the right. So it's just literally alien plus plus. Okay. Alien X or whatever, plus.
Yep.
That's it. Now you need to decide when to do that, and that can depend on the speed of the game, because obviously if you are running on a higher refresh rate display, you would have more updates, potentially, right? Unless you had like a fixed time step, you could potentially use that. I'm not sure how I would do this. I'd probably set it up on a timer of real world time or something like that so that you could control the speed in real world time units.
I think that's the way it's happening right now.
Okay, good. Yeah, like, and then obviously once any alien exceeds that maximum width in terms of cells, or tries to the next time it would, then you reverse the whole direction of every alien.
Yep.
And that's it. And then obviously once, again, this exceeds whatever the minimum cell is as well, then it's game over or whatever. Right? So having like a grid system and a cell system, I think would make this way more robust and way easier to manage actually. Because again, just moving this by some arbitrary amount, like, I don't like that because that also means that like I wouldn't even know like how much you move it by. Like, you know what I mean? It's not like it's not exactly uniform.
Yeah.
You'd have to really like, you'd have to make sure all the values are correct. If you skip a frame or something, or if one alien skips a frame, I don't know. I feel like there are glitches that happen like kind of like that. They're not that common though, are they?
They're not common, especially as of late. They're not common.
Okay, I wonder why that is. Because that definitely shouldn't happen, that some aliens would not move and some aliens would. But yeah, I think having a grid system would just make this so much better.
Yeah.
And again, that also will make it way more, it'll make it way neater, right? Because again, you just literally like, there is no times delta time, there's no speed, there's no nothing. It's just move from this cell to the next cell.
Yeah.
And that's it. And then you just obviously, you take like what cell I am on and you multiply that by the cell size. And then that gives you your world X, your world translation.
Yeah.
And that's it. That's where you render it. That's what you set the translation to.
Yeah.
So that's probably what I would do. Again, like I don't think I've ever made it. I don't think I've ever made a Space Invaders clone before. But I think that's just a good way to take advantage of the fact that they have jittery movement.
Yeah.
Right? Because you're kind of like moving pieces through a chessboard basically. So that's kind of cool. But other than that, yeah, like everything else, like yeah, with delta time as well, I think we talked about like the fact that this should be capped.
Yeah.
Because if it's uncapped, then especially when you have something like a collision test, that becomes dangerous. Because if you move something, right? If you have this is like the game board and this is your alien. Right, if your alien moves by this amount every frame, then that's fine. You'll hit the edge, and then you'll know to change direction and move down or whatever. But if you suddenly have a frame drop or whatever, and delta time becomes greater, then you could jump from here all the way over here.
Yeah.
And then when you move down and move speed down, suddenly you're off the board.
Yeah.
Right, and I think I've seen that happen before.
Like in release, it's extremely rare.
But in debug,
it's pretty common.
Yeah. See, that's not. And again, that would never happen with a grid system.
Yeah.
Because if you're past the end of the grid, you can't be past the end of the grid.
Right.
It's not going to let you do that.
Yeah.
You move one cell.
Yeah.
Right? And then if you're past that, you just move down and you go left. Like, there should never be a case like that. And if there is, of course, you could easily handle that by just saying you cannot go past this grid position.
Yeah.
Whereas if you're in world space with all this stuff going on, it's very hard to control.
Right.
But yeah, that's kind of the problem. And one way to fix this as well is to actually basically be like, if I need to move a distance, you can move, basically divide it into like some for loop or whatever that moves shorter distances. Like, so you basically, instead of moving once this distance, you could move 10 times by like 1/10 the distance and do a collision check every frame, every time. Now that, again, I wouldn't definitely not do this for here, right? And then also with the physics system, that might be difficult because you'd have to simulate physics 10 times or whatever. Right, and that could be, that I don't even know how I'd set that up through Hazel. Right, so that's probably not the best idea, but that's something as well that you could have done. But I like the better solution is basically to say like I have a minimum frame time, right? And by minimum I mean kind of maximum. Like anything above 33 milliseconds is basically not allowed. So what happens is if my frame rate falls below that to like 10 FPS, then my game slows down.
Right.
I don't start dropping frames and not updating the game as often because that causes problems. You're basically saying that no, if you slow down too much, well, guess what? You're playing the game in slow-mo. That's just what it is.
Yeah.
Because we have to keep running all of the code, otherwise the game falls apart.
Yeah.
So it's also okay to do that, right? You don't necessarily have to be like, all right, let's not render a frame and let's still keep the game moving at
Like,
the same
yeah,
speed
yeah.
by using larger time steps and having greater distances. Like that isn't necessary either, because that can definitely destroy the game.
Well, one thing that we talked about, like, essentially right now, my implementation of this would be in every single script on update to put that, like, limiter. Because it doesn't exist in Hazel yet, right?
Yeah.
And you said this should definitely be an engine feature, not like a gameplay feature.
I think in the project settings, you should probably be able to set like a minimum or a maximum delta time. But yeah, at the moment you can't. So of course you could easily just say, you know,
if TS is greater than
well, yeah, you could just say TS equals mathf dot like max or min, right? A 0.033 or whatever, and TS. Right, so that will pick the smaller of two values, and so if this happens to be larger, well, it gets clamped to kind of that value, and then that's it. Now it's gonna slow the game down if you drop below the frame rate. And for those of you asking why a Space Invaders game would be dropping below the frame rate, like there's a lot going on in the Space Invaders game. Obviously, like we have a lot of
90
particles.
actors,
Yeah, we already
actors.
have 111 physics actors. Look at all those stars in the background. They're not physics actors, but there's a lot of stuff going on basically. So of course that's why we have graphics settings to like not fracture enemies and not have like star fields or whatever. So yeah, this has become quite the stress test.
Yeah, I don't think I did a poor job, but maybe like, so for example, right now, until maybe like a week or two ago, you could just win the game by just holding space and just continually shooting because the shots would be entirely random.
Yeah.
Right now, you die within like a second if you're not moving. And the way I did that is essentially check for player's position, compare it to the position last frame, and if it's the same as the position last frame, just shoot. If an alien is above the player, within like some range, on the x-axis, just shoot. And essentially, so right now, if you don't move, you're gonna get bombarded. Yeah. Which
so
honestly,
stay still.
Yeah. But after, for example, I think if there's below 30 aliens, they will do that anyway. So that's why like the game gets harder, and that's why I said you should watch out for your satellites about halfway through the game, because they'll get like targeted a lot more.
Okay, yeah, well, yeah, it does look like it's tearing the satellites apart.
No, so those are random. It's only over the player. Yeah, it's only over the player.
So like that.
Yeah.
And like that, I guess.
But it's within a range as well. Yeah. It doesn't have to be directly over the player.
So where does that happen?
That's here as well.
Oh, yeah, this is the alien controller, right?
Frames without movement.
Oh, okay. So it only happens if you don't move for a couple frames. Is this
initially,
frames without movement?
Initially, or if children is less than 30.
Oh, okay. So you're actually monitoring the player's translation, and then if it hasn't moved, then yeah, okay, I see. That's interesting.
This kind of punishes the no movement.
Yeah, but you can also get away by just doing this. Like it's harder.
Yes.
The controller.
Up till 30. Up till 30.
I mean, I guess you move quite a bit. What do you mean up to 30?
So when there's below 30 aliens, it will kind of shoot you regardless. So for the first part of the game, you can get away, but not later.
Okay, so it's not always like this.
Not always, yeah. So in that if statement that checks to shoot below, if it checks, I think further down, yeah. So if frames without movement is greater than 2, or children dot length is less than 30,
okay,
it'll kind of do.
And children
do
is the aliens.
Yes.
Yeah. Okay. Children, using both.
Yeah, so back then I didn't know that essentially class is inherited from entity, and it was just children you could call. So I had an update, like on update I have a function.
Same thing.
Yeah, that sets it. Yeah.
Yeah. Okay.
And you see, like I'm getting the component that the script is by name as well. Alien holder. I could get just children is equal to children again. Like that code I didn't know I could write that code.
But I think another problem is obviously you have to keep retrieving the children if you're deleting them, right?
Yeah, I have to do it on update anyway.
Okay, yeah. And you were doing that, I guess, right?
Yeah.
Okay, yeah. So, okay, yeah, and if the children is less than 30, then it doesn't matter if you've got the frames without
Yeah.
movement, you still basically shoot. Okay, that's kind of cool. So it gets a little bit harder.
It gets harder, yeah.
What's this shot likelihood thing?
That is entirely useless because this happens on update every frame, and it's like, again, yeah, I have a public variable for it. Like, there's really no need. Like, the only way you can find out is by opening the editor, but I think it's at like 90%, which
Okay.
means there's only a 10% it's not shooting on the first time it hits us, which means
Right.
by the second time it hits us, you can expect a shot.
Okay.
And because it's happening on update for every alien, it's gonna shoot most of the time anyway. So the only thing that's stopping is the timer in the statement above, I think. If the time since shot is greater than
Right,
1.6.
yep.
That's the only thing that's stopping
Okay.
it, really.
Cool. No, I mean, like, again, this is basically what gameplay programming kind of looks like. Like, there are ways to improve this. Like, I don't really, if, like, I don't really like nested ifs like that, like this.
Yeah, well, like, I was talking to you last week, like, I would probably write this stuff different, like,
Yeah.
return or something like that, inverse and
Well,
return.
yeah, but even then, like, yeah, like the problem is that like gameplay programming like is mostly just logic and like trees of logic, right? There's always like, well, if this doesn't happen, then do this, then
Yeah.
do that, and
Yeah,
like,
yeah.
right? Unless you're writing some kind of like AI that learns and like, actually kind of has like some kind of intelligence, like, yeah, usually it's just a bunch of ifs, like
Yeah.
if this then that, if this then that.
Yeah.
Like that's a lot of what programming kind of, well, this like gameplay programming is. One of the reasons why I hate it so much. But yeah, so I can't really blame you too much for this. And I think that like, I don't specialize in gameplay programming. Like I have maybe some ideas of how I would improve this, mostly by just maybe creating some of this stuff, almost using functional programming to kind of create a rule set. And then if it matches a rule set, then I can dispatch a particular function
Right.
or something like that, or at least organize this into states,
Sure.
right?
State machine, when you were
Yeah,
talking about earlier.
kind of like that,
Yeah.
basically, because then you could just say, you could almost, because in a way what you're doing here with your aliens is you could say that they're a form of AI, right? Because obviously like you have this alien controller file that is kind of like, it's in charge of controlling the aliens. And these aliens are these kind of artificially intelligent things that are not very intelligent, but they move around and based on certain parameters, they will execute an action. They will move somewhere, they will shoot, they will target, they will whatever, right? And so, because, again, like the way that AIs usually work is like behavior trees. Well, again,
Right.
we're not talking about neural networks or deep learning or anything like that, but just at the simple kind of case, AIs are all about behavior trees.
Right.
And again, what is that? That's if this and that. And so what you can do is you can almost create like a set of conditions, and you could be like, I don't know, just talking off the top of my head here, but you could, for example, say that, okay, there is a state called like shoot still player or
Right.
something. And then that could be governed by like a set of parameters.
Right.
And then that could have a priority. So, for example, that is priority number one, meaning like, hey, if the player is still, then immediately shoot at
Right.
him and ignore any other action,
Right.
for example. Or if that's false, it could move on to another state, such as, and there could be certain things that you always do, like move, right? But if you want to make them more intelligent, which might be overkill for a Space Invaders game, then you could, of course, just work your way down the list and be like, okay, well, this is the priority one thing. If this happens, then maybe like this uses up 90% of my turn, which is like your frame or your your AI processing thinking frame or whatever. Do this and then move on to the next thing, or maybe it uses up, as I said, it has a cost involved. You can even add costs here. So you have like, okay, shooting costs 90 out of 100 points, which means I only have 10 left over for the frame,
Yep.
which means I can maybe like do this, right? And again, this is getting a bit deeper.
Yeah.
But the point is, like, if you start setting it up into that system, the benefit I think you'll see here is this code just becomes more
Much
readable
cleaner,
and
yeah.
much cleaner.
Yeah.
Yeah. Again, like looking through this code, I think that it does make sense, and I do understand what's going on, but it is slightly hard to read. And again, like it takes a lot of scrolling to see exactly what's going on
Yeah.
and what the different states are.
Yeah.
And again, when you have nested ifs, there's just a lot of states going on. right? Whereas again, if you did organize it into some kind of state machine with named kind of conditions and named actions, then that will just kind of organize it a bit better. So I think that's probably my only advice here. But again, this is fine. I don't really have a huge problem with this. I know a lot of people probably do, but I think that those people should just relax. Like, this is fine. It's just some alien code, man. This is, like, we need to kind of stop this video. This is kind of taking a while. All right, so we actually have, like, a bunch more stuff to look at, but this video has been dragging on for a really long time. So we might do this again sometime. I don't know if you guys, maybe next code review we can do something in C++. I don't know, it's up to you guys. Like, if you want to see, we've still got some particle system stuff that we wanted to cover, because kind of, like, I think you were saying each fractured piece of the alien is like its own script entity, and that could be kind of bad.
The carré, like, you were interested in how that works. And
the carrot.
Carré.
Carré.
Carré. I'm speaking French. Carré. Carré.
Yeah. So anyway, there's a few more things we could definitely look at. Yeah. So let us know in the comments. Let us know if you enjoyed this kind of video. We might maybe have Tim on for some more code reviews, even when we review some of your code. If you guys want to send in your code, by the way, chernoreview@gmail.com. There will be some information in the description box below that will enlighten you as to what you can do. Basically, we accept pretty much any projects, send them in. I'll do a little code review over it, potentially featuring Tim. And yeah, anything else you want to add?
Well, if you are submitting code, like, make sure it runs not only on your computer, but on other computers as well.
Yep. That's true. Also, guys, don't forget to check out Brilliant using my link in the description below. You can get started for free, as I mentioned, and we will see you next time. Goodbye.